Hello, I'm E.G. Arcada Chanda from second year BSCS. This is the my Cartesian program. So first I'll demonstrate it right here. We enter our coordinates. I'll enter the coordinates. And then here is the result. First, it displays each coordinate's location along with its quadrant, then the distance of it from origin. After that, it calculates their distances and then shows which one is the farthest, which in this case is coordinate number 2, and then the closest from origin, which in this case is coordinate number 3. And then that's the end of the program. Now, on the code, it's just over 200 lines. First is we create our array, a 2D array named chords. And in this array, this is where we put our coordinates. So we have the method input chords, short for coordinates. And then on input chords right here, it should return a double array. We have an array with 3 rows, 2 columns. And then we would cycle through all of the rows, and then we input the x and y coordinate on the y column. And then here we check if it's a 0, 0, because we cannot put a value of 0, 0 according to the instruction. And then we check if it's a duplicate, which is handled on a separate method right here. Chords check duplicate. So it's a switch which just compares each input. So for if our current row is 0, we just return because there's no other number to compare it to. And then if it's on the first row, we compare it, or this is technically the second row. If it's the second row, we compare it to the first row, and if it is the third row, we just compare it to first and second. And then after that, we return the chords, which is to the array. And then we have this for spacing. We're now back on main. After that, we output the coordinates along with the quadrant, which it's this part of the code. So for that, we have the method output chords here. We simply just use a for loop to cycle through the 2D array. Here's x and y, the quadrant, which I use a separate method to find the quadrant here. First, we check if it's on an axis, which basically means one of the axis x or y is equals to 0, but it cannot be both because that just means it's on the exact origin point. So we check if it's x or y. If it's neither of those, we check which quadrant it is right here with an else if statement, and then we just print out this quadrant, so that way we don't need to return anything. It will be easier that way, I think. And then we print out the distance from origin, which is also handled by a method uh, point distance that calculate distance. So it's in the point distance class, which is here, and calculate distance, which basically just squares both the x uh no, no. It yeah oh yeah it squares the x and y and then square roots the result. This is so we get the absolute value of it, but without using the absolute value. We just power it by 2 and then square root, but we also add them. Now, the distance formula is actually a bit different. Wait, I'll pull up the thing. uh, there. This is actually the formula, which is it takes both the first x and the second x, which in our case we just compare it. The second point would be 0, so that means we can just remove one of the x, so we're left with x squared plus y squared no, x squared plus y squared, and then you square root it, which is this one. Anyway, after displaying it, we now have another spacing, and then we output the farthest from origin, which is this part of the code. In this case, we use the find point method, which takes coords and a string, which I call function. And then this one is the farthest. For if we want to get the closest, we use the same method, but for the function, we use closest. I made it this way so I'd only have one method for them, but it could branch out to do different things. So if we go to our find point method, here we need to calculate their distance for each coordinate, and if I didn't merge them to this one find point, I had like individual of them, I'd had to calculate this twice, one for each farthest and closest, which would just make the code longer. And then I have a debug here in case I want to print the coordinates, but this is a bit old since I now made it so it prints the coordinates on the upper part. I'll just delete it. Now, the reason I made it this way is because I felt like if I made a method that just, let's say this is the method, it takes in the chords 1, 2, and 3, which is basically just this, which I could have just replaced with this. I'll just put the method here, but it makes the code really long, and in my opinion, it's harder to read just compared to this, just this one. So that's why I made it that way. And then here's the switch for the function, which if it's farthest, define the farthest coordinate using these coordinates, and then closest would be also like that, but we find the closest. So after we calculate it, which we use the same method as before for displaying it here, we then go to our find farthest method, which is this one. This is how we find the farthest. We use mat.max to find the largest of them. We can only have like 2 values for mat.max, so what I did is I nested another mat.max here, which it worked. And then here I didn't use an if-else statement because in the case of, let's say, there are 2 similar distances, it is true that we cannot put similar coordinates. Like in this case, they're both 1 and 5 on x and y. We have an error that we cannot input duplicate coordinates. But in the case of 1, -5, and then -1 and 5, they are technically not the same point. They're not equal points. They're on different quadrants. So in that case, they still have similar distances from the origin. So this is why I use this if statements instead of if else and compare each coordinates that way. So if we look at the closest coordinate, you can see that it considers both coordinate 1 and 2 as the closest because they are equal. And then this is just the printout for this. And then find closest, it is the same, except instead of mat.max, it's now mat.min for minimum. And then that concludes my program. Thank you.